So today we're starting our unit on probability. So to begin the unit, we played rock, paper, scissors with our partner in class, and you record your findings. So if you want to play it 18 times, if you want to play it with a sibling or a parent, go ahead and do that and record your findings. And so what you want to record is how many times decide who's going to be player A and who's going to be player B, and if you got a tie. And so these three numbers should add up to 18. So the rules for rock, paper, scissors, if you don't remember, is you do rock, paper, scissors on your hand and then go, and rock breaks scissors, paper covers rock, scissors cut paper. If you each have rock, the same thing, then it's a tie. So go ahead and pause the recording and play rock, paper, scissors with your partner and record your findings. Okay, so you should be back from playing rock, paper, scissors and have recorded your findings. So now we're going to use the class data to calculate the following. The mean. Mean is the average. We can't do that because we don't have a class. So mean is the average, median is the middle number, and the mode is the number most often. So when we had a whole class information, we could do that, but since we don't, we can't do that. So number 2, it says list all the possible outcomes of the game when two players are playing. So on the back of your handout, you should have a page that's blank somewhere in there, or just get a blank page. We're going to list out all the different ways you can win. So player A can do rock, paper, or scissors. Then player B can choose rock, paper, scissors, also. So these are all your options when you're playing with two people. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, you have 9 possible outcomes. Another way to figure out how many possible outcomes you have is, without doing a tree, is to look at how many outcomes A has, which is 3, how many outcomes B has, which is 3. We already know our total outcomes for this scenario is 9. So what do you do to 3 and 3 to get 9? You multiply them together. So the way you get the total outcomes is you take total possible outcomes for first player, total possible outcomes for the second player, and then you multiply them together, and that gives you your 9 total outcomes. So back over here on your paper, we're going to put 3 times 3 equals 9 total outcomes. And it says list all the possible outcomes. I'm going to just say C tree chart, because that's what we did on the last page. Now organize possible outcomes. So we're going to look, if we had player A and player B, we're going to look at this first, rock and rock, that would be a tie. We're going to do a tally for tie. And then we have rock and papers. Rock covers paper, so A would win. And then we have rock breaks scissors. I'm sorry, scissors, wait. I'm sorry, rock covers, paper covers rock, B would have won on that one. And then rock breaks scissors, A would have won. Sorry about that. Now go to B, and we're going to do the same thing with B. Paper and rock, so A, paper and paper is tie, and then paper and scissors, B would win. Now we're going to do scissors and rock. Rock breaks scissors, so that would be B. Paper, scissors, cut paper, so that would be A, and then scissors and scissors would be a tie. So when you see, we looked at all our different possibilities, we organized our outcomes, so we have equal probability of A winning, B winning, or getting a tie game. So how many different wins were there for A? There was 3. So what is the probability that A will win? You take your total possible outcomes, that goes on your bottom of your probability, and on the top of the probability is 3. That's how many times A won. We can reduce that to 1/3, so 1 out of every 3 times A would win. Now on B, we do the same thing. 3 times probability that B would win, and so that's 1/3. Is this game fair? Do both players have equal opportunity of winning? Since they have the same probability of winning, the game is fair, and they have equal opportunity of winning. Does our class experiment agree with what we've calculated? Well, we didn't do the class experiment. Usually it's close. So now, number 8, if there are 3 students, how many possible outcomes would there be? Remember, let's go back to our tree. This is player A, this is player B, and now we can go to player C. Sorry, it's getting a little crowded. So we have all our different possibilities over here, but let's use our calculation. Player A has 3 choices, outcomes, B has 3 outcomes, and C has 3 outcomes. So we have 3 times 3 is 9, times 3 is 27. We should have 27 total possible outcomes. And that's exactly how many we have. So you don't have to do the tree if you want to use the calculations here. So if we have 3 students, how many possible outcomes would there be? 3 times 3 times 3 equals 27. And on our tree chart, we proved that. So let's change the rules. Player A wins if all 3 are the same. Player B wins if the 3 hands are different, and C wins if 2 hands are the same. So calculated the probability of each player winning. So let's go back to our T chart. We're going to first look where A wins, which is where all 3 hands are the same. So that would be rock, rock, rock. Paper, paper, paper. Scissors, scissors, scissors. So where player A wins, there's only 1, 2, 3 times. So this would be 3 out of 27. So far, that doesn't seem very fair for A. Now let's look at B, where all 3 hands are different. I'm going to use blue to highlight that. So let's see. Rock, rock, paper, scissors. Rock, rock wouldn't work. Rock, scissors, scissors. paper. Paper, rock, scissors, paper, scissors, rock. Scissors, rock, paper, scissors, paper, rock. Okay, so it looks like 1, 2, 3, 4, 5, 6. 6 times, so 6 out of 27, this was reduced to 1/9. If all 3 hands were different. Now see if 2 hands are the same. Let me get pink out for that. So we have rock. So we'd have rock, rock, paper, or scissors. So that would be 2. So rock, paper, rock. Rock, paper, paper, that's 2, the same, right? Rock, scissors, rock, scissors, scissors. So it's going to be all the ones we haven't already highlighted. Goodness, I think I want to be player C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So C wins 18 out of 27 times. These should all add up to 27. 18 plus 3, 21, plus 7 is 27. So we have all of our different options have been used. So calculate the probability of each player winning. That's what we did here. So player 1 would be 1 out of every 9 times. Player B, I'm sorry, player A. Player B would be 6 out of every 27, and player C would be 18 out of 27. So if they change the rules, I would definitely want to be player C. Okay, so let's move on to our probability notes. And this is where we're just going to talk just a little bit more about probability. So when we think of probabilities, when an event is blank to happen, the probability is 1. When an event is certain, that means it's absolutely going to happen. Let's think of an event. The sun rises in the east. It's going to rise in the east. We know for sure it's going to rise in the east. So the probability is 1. We can also think of this as percentages. If it's 100% chance that it's going to rise, the sun's going to rise in the east, if we take a percentage, we make it a whole number, we move our decimal 2 places to the left, that becomes 1. So if it's 100% certain, then we know the probability of it happening is 1. When the event is will not happen, so let's say the sun rises in the west. We know for sure it's not going to happen. The probability of that happening is 0, or if we're going to think of as in percentages, also 0%. All other probabilities are determined by the number of favorable outcomes, meaning the number of outcomes you're looking for, over the total number of possible outcomes. So let's look down here at our 52 standard, where we have a deck of cards, 52 cards. Determine the probability of certain events happening. What is the probability of drawing a 5? We have 4 5s in the deck, so that would be 4 out of 52. We could reduce that to 1 over 13. So I want you to pause the recording, and take a minute and work through 2 through 5 on your own. What we did in class is we worked with shoulder partners, then we came back together and we checked our answers. So pause your recording, work through 2 through 5, and then come back and check your answers. Okay, you should have paused and did 2 through 5 on your own. So the probability of drawing a red ace, there are 2 red aces. So that's going to be 2 out of 52, and that reduces to 1 over 26. The probability of getting a number greater than 5, 6, 7, 8, 9, 10. I did it just numbers. I only counted numbers, so I had 5 times 4 suits, 20 over 52. If you counted, which reduces to 5 over 13, if you counted your Jack, Queen, King, you'd have a different answer, but I just counted numbers. The probability of getting red or black would be 1/2, because half the deck is red and half the deck is black. Or you could have written it 26 over 52, which is going to reduce to 1/2. And the probability of getting an 11. There's not 11 in the deck, unless you're counting a Jack, and I don't think they're counting Jack, so that would be 0. Okay, let's go over on the back. Now we have 11 tiles with 1 letter from the word probability on each. Find the probability of each outcome if you randomly choose a letter tile. So again, I want you to pause and try to work these on your own. Your total possible outcomes are 11. So answer each question and then come back and check your work. Okay, you should have answered these independently. So the probability of a B, there are 2 B's, so it is 2 out of 11. The probability of an I, of not an I, there are 2 I's, so there are 9 letters that are not an I. An E, there's not an E in there, so that's going to be 0. A vowel, 1, 2, 3, 4. We're not counting Y in this case. 4 over 11. Not a B or a Y. So we have 2 B's and 1 Y, so that would be 3 minus 11. 8 over 11. And an A or a T. We have 1 A and 1 T, so that's going to be 2 over 11. Now we have marbles in a bag. 12 blue, 8 green, 5 yellow. Without looking, you reach in the bag and draw 1 marble. Whenever you're doing these, you have to get your total possible outcomes, so we have to add 12, 8, and 5 together. So our total outcomes are 25 different outcomes. Now go back and pause, answer 7 through 10 on your own, and then we will, you can check your work. Okay, you should have done 7 through 10. We have 12 blue, so we have 12 out of 25 probability. We have 13 that are not blue, so that should be 13 over 25. We have not red. There's no red, so we're not going to draw red. It's certain to happen. You can write it 25 over 25, or you can just go straight to 1 because we know it's certain to happen. Or a yellow or a blue. So that's 12 plus 5 is 17. So I hope you enjoyed your introduction to probability. please come by and see me if you have any questions. Thank you.